Hi and welcome to MSc. In this lesson we're going to be looking at function transformations, specifically translations. So the general form of a translation looks like this, and at first this can be pretty daunting. We have some function g at x, which is equal to f, and then there's at x minus d plus c. So there's some stuff we have to unpack here to figure out what's going on. It appears as though we have some function that maybe originally was f at x that's now been transformed into this new function g at x. Specifically here, it's been translated, it's been slid side to side or up and down. And you might refer to this as a translation, or you can slide it or shifting it. So let's break down these parts. The d value here is the horizontal translation, and that's going to translate it d units left or right. And I'll explain the left and right piece here in just a moment. Likewise, we have the c value, and c is the vertical translation, and it's going to shift it c units up or down. So let's look at this left or right piece first. This right will happen when we have a positive d value. And there's a little bit of trick to this, and sometimes I talk about inside the brackets here being like opposite land. And so we have a positive d, but we'll notice here in the equation that it's negative d, so x minus d. So this is x minus a positive d value. So d is just the number here, not the sign necessarily. So if we see an x plus d, that actually means that the d was negative, because two negatives will make that be a positive. The left will happen if we have a negative d value. And that will lead to this expression looking like x plus d. Again, we talk about kind of opposite land in there, where we have this signage flips. And we're kind of used to that from vertex form of a parabola. On the other part here, we have up and down. This one's a little bit easier. If it's a positive c, it's moving it up. And if it's a negative c, it's moving it down. And that seems to be a little bit more intuitive for folks as they work through these. There's no sign flipping here. Up seems to be positive, down negative. That seems to make sense. Right being positive and left being negative also makes sense just from a number line standpoint, but it's this flipping of the sign that can be challenging as we get into these translations. So let's look at one example here. And I chose to use the example of a parabola here. So we have a general parabola. This is as basic of a parabola as we can get. I'll graph it for you here in a moment. But this is just f at x is x squared, right? So this is a non-translated, non-shifted, or stretched, or anything like that parabola. Here we have our transform function. It's g at x, and now we'll see that this is of the form f x minus d plus c. So that's really what we have here, just like we just saw. And g at x is equal to this. Let's rewrite g at x now, because now we know what this f at x is. And how do I write this out? Well, we'll notice here inside the f at x bracket, I have x plus 3. That means this plus 3 happens right next to the x. So I have to put it in right beside the x, and then I square the whole thing. So this f at x, here this x squared, we put this, whatever's in the bracket goes right in there where the x goes. I also have this negative 5 being tagged along on the end. And so this is my transform function g at x, which is a translation of the f at x function. So this parabola has not been stretched or flipped, it's just been slid, left or right or up or down. So let's go through and talk about this. I look at this and I see a 3, but I also see a positive here. So what that tells me, because it's supposed to be x minus d, what that tells me is that d is equal to negative 3. And this will imply to me that we are moving 3 units, and we're actually going to move to the left here because d is negative. And even though it looks like the positive there, and that can be a bit of a trick for this. Then we look here and we see the negative 5, and this implies to me that c is equal to negative 5. Again, no sign flip. And that implies then that we're shifting 5 units down. Okay, so let's take a quick look at what this looks like on Desmos. and see if we can see this 3 units left and 5 units down. So looking on Desmos, here I have my y equals x squared graph plotted. Nothing super special about it. If I add this new one that we've just transformed, the x plus 3 all squared minus 5, we now know that it should move things 3 units to the left and 5 units down. So I should get my new vertex right here. So let's see. Sure enough, I do. That's awesome. But it doesn't just apply to the vertex. And you can see this is like vertex form, right? And we're used to that. Sign flip and everything already. If I look at another point, for example, right here, 1, 1, I should take that and be able to move it 1, 2, 3 to the left and 1, 2, 3, 4, 5 down. And I should get -2, -4. And sure enough, that works. So this doesn't apply just to the vertex, it applies to the whole parabola. So clicking back to our note for a second, we can make a note that this is vertex form, and we're used to having the vertex of this parabola be -3, -5, right? We're used to that happening with the sign flip already, which is why I chose the parabola, because chances are you're most used to those parabolic functions. Looking back here, we can see, of course, that is the case, as we found. The other cool feature that you can play with on Desmos is what I've set up here with the -d plus c. And if we make sliders out of those, then we can start to look at what this would look like. So allow me to add this graph. I'll take the other graphs off here so we can see. And look, if I have 0 values, it's just my standard parabola. Nothing special. But now we can start to see what happens as I move it to the right when d becomes greater than 1, or when it moves to the left when d becomes less than 1. And I can do the same now also for the up and down piece. I can move it up when c is positive, and I can move it down when when c is negative. And this will allow me to set it to the values that I want, such that it should match this parabola when I turn it on and off. Playing with these sliders on Desmos is a great way to play with all of the transformations that you'll see with functions, specifically here, as I've shown you, with translations. I hope this brief run through has been helpful. If it has, please consider liking the video and subscribing to the station. Thank you very much for listening and watching.